Hi class, welcome to Research Methods. I'm Dr. Shantz and we are spending our video on Chapter 12, which is Descriptive Statistics. The different statistical techniques we use to just describe what is there in the data set, whether we're describing the sample or describing particular variables within the study or the data set. Quick overview, we're going to talk about some measures of central tendency, measures of spread, and these you've probably recall from your Elements of Statistics class. But we're going into when to use which descriptive statistic and also what graphics help us explain the sample characteristics to a reader. Our measures of central tendency are pretty much the mean, the median, and the mode. And you probably recall these from your stats class. The mean is the average of all the scores. The median is the middlemost occurring score when they're all lined up from lowest to highest. And the mode is the most often occurring value. So let's take a look at when we use each of these. The mean, median, and mode often rely on what scale of measurement the researcher is using for that particular variable. And what do I mean by which scale of measurement? That's back to our psychological measurement chapter and the types of variables like your nominal, ordinal, interval, and ratio scales of measurement. So the first question when you're going to summarize descriptives about a variable is to know, are you trying to describe a continuous variable or a categorical variable? It breaks down to those two first. If my data are measured using an interval or a ratio scale and they happen to be normally distributed, then I want the most sensitive measurement of central tendency, which would be the mean. Tips for reporting the mean include that sometimes you'll see the mean represented by a capital M that's italicized. For example, in this sentence, the participants found less evidence of injury in the car crash case, mean of 5.7, than the bus crash case, mean of 8.8. We would know that the average score for car crash cases was 5.7 compared to the average for bus crash cases, which was 8.8. We know which one's higher because on average, 8.8 was higher than 5.7 in the cars. A couple of APA things to look at here. The M is italicized and there's a space between the M and the equal mark and after the equal mark. And mean is typically to one decimal place when we're writing about it in a paragraph. So just some tips there. There are problems with using mean because it's sensitive to extreme scores, also called outliers. An outlier, an extreme score that is much higher or lower than the rest of the scores in the distribution. The impact of an outlier is more pronounced when the sample size is small as well. So let's look at the median. If the data are measured using an ordinal scale, so recall that's like first place, second place, third place, that ranking system where first place is better than second place and second place is better than third, but we don't really have consistent distances between first, second, third, so on. An ordinal scale is just like a rank. Or you could have a situation where the data are measured using interval scale, but there's outliers in the data. When we have that kind of situation, we use the median. And the median is that middle occurring score. In fact, let's try figuring out the median here. The median is relatively insensitive to outliers. So if we place a whole bunch of scores in order from lowest to highest, and we have outliers, then they would be way at the ends. And since the median is just the middle or central of all the scores, then it's not going to be as affected by the outlier scores, right? So here, if we got the mean, which would be the average of all of these, and again, the mean is sensitive to outliers. The mean here is 35.4 of all these scores, but the median is only 25, the middle occurring score. Unlike the mean, the median is not sensitive to outliers. This can be really helpful when you're trying to let your reader know about the characteristics of a variable, but also let them know that the mean is different than the median. And again, if you do use median, report the mean and the median anyway. And it might look something like that. With outliers in the data, age was reported as an average of 35.4 years and the median of 25 years old. That helps the reader know that the mean was being impacted by outliers in the data. Okay, what if the data are measured using a nominal or ordinal, or in other words, categorical variable? And then we're going to use the mode. And the mode is the most occurring item in that data. It's the simplest descriptive to calculate. It's just how many are there. But it's also the least precise. To find the mode, you list all the values and you tally how many times that value occurs. And the most frequent one is the mode. Some examples. If we ask the whole class what their most purchased food item was, pizza, burgers, salads, whatever, and then we listed all those food items and found out which one occurred, like how many times did burger come up, taking a tally of how often. And we find out that, let's say, pizza was the food item purchased most often, then the mode of that variable would be pizza. You could also get the mode of other categorical variables, like college year. How many freshmen, sophomores, juniors, or seniors are represented in our class, and which one is most often occurring. When we find that, we found the mode of that sample, that it's mostly, let's say, juniors. Vehicles on the road, which is the most often seen vehicle on the road, or even genres of movies watched by college students. Notice that all of these are categorical variables. They're nominal, like most purchased food item is just a variable that's categorical, and it's got these different types: pizza, burger, salad. Same with college year, vehicles, and movies. That's the main gist of our measures of central tendency. Let's take a look at an example from our class of describing a variable using descriptive statistics. I'm going to move over to Canvas and go to our exam 1. In here, I want the quiz statistics. So this gives us a summary, descriptive statistics, on our exam 1. The average, the mean, was 86%. The range from low score to high score was 66 to 100%, with a standard deviation of almost 4, an average time of 1 hour and 6 minutes. So what would be the mode here? That's tricky. The most often occurring score is going to be that score right there. Let me see if I can get that bigger to see if we can see what it is. We have 80% and 90%. It looks around like an 87. If that's 90, that's going to be 88 or 87 right there. That's the mode. The mode doesn't have to be the mean. Like we said, the mean was 86, but the most often occurring score is that one right there. Notice we have a low score, we have a very high score, but other than that, it kind of just is that curve. Okay, back to our PowerPoint. So measures of central tendency that we've been talking about, the mean, median, and mode, are really helpful in describing the central score in a data set with a single number. But measures of central tendency are not giving us the full picture. Here we move into another type of descriptive called measures of spread. Measures of spread, like measures of central tendency, are descriptive statistics that try to use a single number that best describes the variability in a data set. Now, why would this matter? Consider the following data sets here. If we have set A with these numbers, set B with these numbers, and set C with these numbers. What are the means in each of those sets? Well, the mean for set A is 4, the mean for set B is 4, and the mean for set C is 4. Well, then how about the medians? Well, the median, the middle occurring number in set A is 3, the middle occurring number in set B is 4, and in set C is also 4. Okay, then what are their modes, the most often occurring number? Well, in set A, the most often occurring number is 3. Set B has a mode of 4, and set C has a mode of 4. Did any of these measures of central tendency really tell us what is different about these samples, about these three sets? Not really. Are they the same? They're definitely not the same. But the measures of central tendency really did not get at what is different about those three sets of data. So let's talk about the basic forms of measures of spread. We have range. Range basically gives us an idea of how far apart the lowest and the highest numbers are in that data set from each other. So to find range, we subtract the lowest from the highest score in the distribution of scores. This is the simplest measurement of spread, so it's not as informative, but it's very easy to get. You just subtract the lowest from the highest. We do have problems with range because it does not take into consideration what's going on with the numbers between those two most extreme points as far as the lowest and highest. For example, all of these distributions have a range from -5 to +5. So according to the range, they're all the same. It does not consider that the black curve shows most scores close to the mean. The blue, the scores are more spread out than the black curve. And for the red curve, the scores are most spread out. To discuss that spread within the distribution, we go to standard deviation. It's the average distances between the scores and the average of all the scores. So the advantages of standard deviation is that it's in the units of the measure itself. For example, when we had that list of numbers that could be someone's ages, if we have years, then the standard deviation is also in years. We could say the average age is 35.7 years old, and the standard deviation is 3.2 years. The standard deviation is in the same units of measure as the mean. So it makes it easier to talk about when you're trying to write it up or tell someone about that particular variable. There are issues with the standard deviation. It also uses the mean to help calculate it. That means that it's also sensitive to outliers, just like the mean is. This graphic I've put on Canvas for you in our module. You can go take a look at that, because we'll probably be using that later as well. So in your modules in Chapter 12, in your Resources tab, is your graphic of the normal distribution. I also put a little video here talking about outliers. It's short, it's like, I think 5 minutes. And while we have this, let's go ahead and take a look at our exam stats again. When we're looking at this breakdown, right, we have our curve here. We have some outliers, kind of low type outliers. The 100 could be considered a high outlier, but it's kind of closer because there are several scores in the 90s as well. So it's more like, here's our curve with a couple of outliers low. But here's what we want to look at. The mean is 86%, but the standard deviation is almost 4%. Again, the standard deviation is in the same units as whatever the mean is. So looking at our curve right here, that means between the mean and the first standard deviation is almost 4%. So if the average is 86, right there in the middle, then 86 plus 4, 90, would be that first standard deviation there at the top. And 86 minus 4 minus 1 standard deviation would be 82 right there at the -1 standard deviation. So from 82 to 90 is 68% of all the scores in the class. We can look at that again later, but I wanted to show you how to use this graphic that you have in Canvas. Alrighty, let's take a look at the last type of measure of spread. It's called variance. Now, variance is a more difficult concept. It describes how much a random variable, so not a categorical variable, they're talking about a continuous variable, how much that variable differs from its expected value. It's not used much in RM1 level because it's difficult to explain to your reader, how much a random variable differs from its expected value. It's also not in the original unit. It's calculated by using squaring of the standard deviation. So again, if we have a standard deviation of 4 on exam 1, 4%, then the variance, the variation differing from expected value for our exam scores would be 4 squared. So 16% squared. Now, how do we go about describing what is percent squared to someone? That starts getting like weird. So while we do use variance in statistics, it's not something we're going to use a lot at RM1 level. But this tip, calculated by squaring the standard deviation, is a good one. Because if a test asks you for variance and all you have is standard deviation, all you have to do is square it. Or if a test gives you variance and you need standard deviation, you just take the square root. Just got to pay attention to which direction you're going. I wanted to spend some time looking at visualizing data. And again, it comes back to, are we talking about a categorical variable or a continuous variable? Figure that out first, because it makes the difference on what you're describing about the variable and which statistics you're using for describing the variable. When we're talking a categorical variable, so a category, a nominal, an ordinal type variable, you're typically going to use either a bar chart or a pie chart. And this gives us the idea of two things. It tells us how many, like how many people preferred blueberry, and what percent of the whole. Like that's almost like 25% of the whole sample. And that's the two things you're reporting about categorical variables, is how many, the frequency, the mode, and what percent of the sample does it represent. When we're looking at continuous variables, now we're looking at mean and standard deviation. And the different ways we would visualize this data are with a histogram, which shows how many times we had that amount, right? So $900 looks like the most often occurring one. That would be the mode of salary. But his histogram shows us the count of all of them across that sample. Or sometimes when we have two continuous variables, we can use a line chart. Like here's age, which is continuous, and average donation amount, average number of dollars donated by high school students, by the age of the donor and how much they donated. Both of those are continuous variables, so they make sense for a line chart. And looking at histograms, you're going to start making judgments on what that distribution looks like. Like when we were looking at the exam 1 data, right? And we look at this distribution. If we just draw like a hypothetical line over this curve, does it look normally distributed, or does it look like it's leaning to one side or the other? When distributions are leaning to one side or the other, they're called skewed. And the way you tell which type of skew it is you look for the tail. Whichever direction the skinny tail is going, that's your name for that skew. This one is a positive skew because the tail is going off to the positive side. This one is a negative skew, with the tail going off towards the negative numbers on a number line. Okay, that's it for our highlights in Chapter 12. We discussed measures of central tendency, measures of spread. Keep in mind, it depends on what type of variable you're looking at. That's your first question every time. Is it a categorical variable or a continuous variable? Then that tells you what type of summary statistic you're going to use to help describe it, and what graphs or visualizations you want to use. If you have any other questions about the chapter, please post them on the chapter Q&A.